up 4.7. I did, yes. So we did all this stuff, right? We did, listen, sometimes you'll see like in part B, see how they have it like B minus MX. You understand it's really the same kind of thing, right? So if you see it like that, it's still MX plus B because the community property. Let you, and hey, the negative comes with it when you're moving around, yeah? Okay? And then once you have your equation, then like any other question they ask, it's a matter of just plugging into that equation you got, right? So down here, we had our equation, and down here they asked, okay, so now the supply reaches 150, right? So you just replace the n with a 150. Of course, I like to put it over there. It shouldn't bother you, I don't think, and solve it for the number of days, right? And well, okay, hey, when we talked about this, this is one of the things I teach in my finance class to the college kids, right? Yeah, we have a lot of college courses here, yeah.
Oh, I think really you take college, it's like.
Well, they are, right? If you are a student here and you're taking college credits through Corning or TC3, you are a college student, really.
TC3 is on our space.
And that makes me a professor. Yes.
How tall
6'4".
You're taller than my dad. Were you basketball player?
Or we could do this.
Wait, can I stand next to you real quick?
So any company has, well, they have a lot of costs and expenses, right? But they generally fall under two categories. Remember what they are? Variable expenses and fixed. We talked about the difference between the two, right? The variable, like, that's the cost to make a certain number of widgets, and it changes, it varies. Hey, it's a rate of change, isn't it like M? Your variable cost, wouldn't that be M, like slope, rate of change?
Wait, I thought we did this yesterday.
I know, I'm reviewing. And the fixed cost, the cost that's always the same, no matter if you make 0 widgets or 10 million widgets a day, that's the B, the y-intercept, the starting amount, right? Okay, so we covered that, right?
Yep.
Let's go to the next page. So what's going on in exercise 3, Hannah? This has, you know, you like animals, right? You'll be a biologist. Read that, will you?
Biologist, is that estimate?
Yep.
The number of deer in Rhode Island in 2003 was 1,028. And in 2008, it had grown to 1,488.
Now, hang on there a second. Does that sound like a couple of ordered pairs?
Yeah.
All right.
2003.
Well, hey, before we do that, I'm not sure I want to use the actual 2003. Read that. Keep reading, Hannah.
Biologists would like to model deer population P as a function of the years since 2000.
Year T since 2000. So when they say it kind of makes it a little bit easier when they said since 2000, because we can now look at 2003. We don't have to use 2003, right? Like,
Yeah.
how many years after 2000? Since it starts in 2000, how many years after is 2003? Okay, so give me, if this is an ordered pair, what would it be then? What comma what?
2003.
No, I just got
2001.
3 comma 1028, yeah? After 3 years, there's 1,028 here. And now how about this 2008, it had 1488 deer. What would that order be?
148.
Oh, 1488, right? Okay, so that's nice, it starts in 2000, it keeps the numbers simple. All right, so we have 2 points, and you guys know you can find slope. Those are x1, y1, x2, y2, right? y2 minus y1 over x2 minus x1. Let's see, oh, look at A. What's that say? I think we just did that, didn't we? I got kind of ahead there. Yep.
Yeah.
So we'll just write them again. So we have 3 comma 1028 and 8 comma 1488. But I do want to say these aren't, we're not using, they don't want us to use X and Y. What do they want us to use?
T and P.
T, right? So this would actually be, we'll call that T1 comma P, is it P? Lowercase p they're using, P1. And this point would be what? T2, comma, P2, right? So when we do that slope formula, right, which I bet they'll ask us to do, determine a linear, oh wait, let's go, look at this. Now they're going down. B's down here, I'm gonna go over there. Yeah, probably.
I did that last night. I was taking my notes and I was like so confused.
Okay, so now they want us to calculate, what does this say? Delta P over what is that known as?
I don't know.
Yes, you do.
Delta max.
Slope, M. Delta means difference, change in, subtract, y2 minus y1 over x2. Well, P2 minus P1 over T2 minus T1, right? Okay, so let's do that.
1,488 minus 1,028 over 8 minus 3.
Let's just we'll call this M equals, right? Because that's our slope. Yep.
Is it fine if I put delta P over delta T equals and then that?
Sure, yeah. But I do want you to put an M equals right before that, just so you lock it in your brain. So you get 460. That's 460
Equals 92.
deer over 5 what?
Years
Years. I want to put the units, right?
divided by 5.
Yeah, let's get this as like a per year thing. So what would it be?
92 deer per year.
2 deer per 1 year. All right, so that's the rate of change. That's the M. Slope M, the rate of change, right? Okay.
This is something that DEC would do. Not DEC.
Say that again?
The deer hunting.
DEC, oh, the DEC, Department of Environmental Conservation. Yeah. Hey, so if you're going to get into that, you're going to need to model populations of wildlife, right? Yeah.
You have to know that people cut deer after. Some people bring you deer for hunting.
Mm-hmm.
Like after they shoot it, they bring you to like a butcher shop or something.
Oh, all right. So, Part C, give a physical interpretation of this thing. What is? Go ahead.
Each year, the deer population increases on average by 92.
Yeah, the deer population is increasing by 92 deer per year. Yeah? Okay. So, what did I just say?
Each year.
Yeah, you said that. Just for spite, I'm going to write the deer population is increasing by 92 deer per year. It rhymes. Now, this is important, right? Especially when you're collecting real-life data. This rate of change of 92 is only from between the years 2003 and 2008, right?
By 92.
Oh, by. What happened to the Y? Deer per year between, this is important, 2003 and 2008, was it? And the reason it's important to include that is because, like, when you collect data, you can't assume that that like rate of change will go on for too much longer. I mean, there's some reasonable time. Maybe you could say, yeah, maybe the next few years we'll do 92, but other things happen, right?
Supposedly deer don't have coronavirus too.
I don't think so.
I've seen it on the news.
All right, let's go up here to Part D. Determine a linear relation. That means write an equation with P and T in it, right? You know, instead of y equals mx plus b, what are we going to have?
P equals MT plus B.
mt plus b, right? Well, the b is the starting amount. Do we actually have that?
No.
Yeah. Well, how are we going to find that? Do we have an m? Good grief.
You will do 1,028 equals 92 times 30 plus 8.
So we have some sample xy's, don't we?
Yeah.
Well, TPs. Does it matter which one we use?
Yeah, you wanna use the 3 because it's.
Oh, well, yeah, I mean, it really doesn't matter, and I don't know that any one's gonna be any easier. You're gonna use a calculator, right? Probably. So let's use, what did I use? I used the 1028 one. Let's use the 3 comma 1028. So the P is gonna get replaced with what? Anna, what am I gonna replace the P with if I'm using this one?
1028
1028 equals, hang on. Hey, Hannah, what is it gonna equal? What's our M? What's our M? 92. Right? What's our T from this point?
3.
We'll pretend that didn't even get said. 3 plus B. You guys can solve that, right?
Yeah. You don't have to, you're solving for B.
That's what we're doing. We're getting it. What's 92 times 3, you guys? 276. So 1028 equals 276 plus B. Subtract 276 from both sides. What do you get?
752.
Everybody else get that? I'm not going to show minus 276, but what was it? 752? Is that what you said?
Yeah.
Okay, so now let's write the equation. It's what? P equals what?
92.
92 T
Plus 752.
plus 752. So now we have our linear equation. Hopefully you guys know how to find B now when it's missing, if they give you a point. You don't?
Why don't you never at me?
You what? You just, okay, so you do know, but you shook your head no. All right. So now we have that equation, now we can use it, like, usually the follow-up questions, you just like plug and chug, right? Now that we have an equation. So part E, how many deer does it predict? We're in Rhode Island in the year 2000. Okay. So 2000 is a time, yeah? What is the value of our time in the year 2000?
We're almost at the 2002.
What is the, okay, well, read the last sentence again of this.
What does this represent about the 1 year?
Read the last sentence.
Biologists would like to.
Since 2000. So what is our value of T in the year 2000?
0.
0, right? Because remember it starts at 2000, so that's our time 0. No years have passed yet, that's the beginning, the initial time. So this would be T equals 0 for that, right? So what do we plug in?
T equals 92. 0 plus 7.
92 times 0 plus 752, which actually equals what? 752 deer. That's our y-intercept. That's our beginning amount. Like, if we're going to graph it, right? You go up the y-axis, put a dot on 752, and your rise and run would be up 92 and over 1, wouldn't it?
Yeah.
All right. How many deer does the model predict for Rhode Island now? What year is it now?
T equals 21.
So this is the year 2021, right? Which would be T equals, now I would say that we're probably outside the range of being useful for the data they collected by now, but we'll do it anyway, just as a side note to think about if you're ever going to compile something like this. We're probably outside, like other things are bound to have happened between then and now to affect the deer population. So now it's just plug and chug, right? So it's P equals what?
92
Times
21.
21, so it's 92 deer per year for 21 years, plus the starting amount, which was 752. So what is that population? You guys tell me.
2,684.
Why don't you guys make sure you get that? Go ahead. here. All right, does anybody have any questions so far?
Yeah. 84.
Oh, my 4 looks like a 9, I guess. So if you notice, these are all kind of working the same, like, right? You find a slope, M, rate of change. Usually have an ordered pair of coordinates somewhere in the problem. You use one of those as a sample x, y to find your b and write the equation. Then use the equation to answer a follow-up question.
What does perpendicular mean?
That they intersect at right angles, 90-degree angles. I just told you. So you could either intersect at, say, a 30-degree angle, that's not perpendicular. Looky.
Cookie.
Here, looky.
Oh.
Perpendicular means two lines that intersect at 90-degree angles, right angles. All right, hey, bathroom. So what we got going on in number 4, Conklin?
Water is draining out of a bathtub such that the volume still low. Gallons is shown as a function of number of minutes. It has draining.
Okay, so what's the input for our thing here? Hang on. What's the input?
And
Minutes is the input. And what's the output?
Gallons.
G for gallons. Okay? So they made a table here, right? Before you drain, start draining the tub, right? 0 minutes have gone by. There's how many gallons in the tub? 62. Does this look like a starting amount?
Yeah.
In other words, a B, your initial amount, when time is 0. Okay. And then after 2 minutes, how many gallons are left?
28.
So the rate of change, right, is the gallons changing, and that's the slope, right? So what would you say? What could you say without any calculations? You be quiet. What could anyone else here say about the slope of this situation?
Like, what do we do to get this going down?
Going down, which means what kind of number will the slope be? Negative, right? You all agree to be a negative slope? Just thinking before we get to it, right? All right, calculate the average rate of change of G gallons over 0 to 2 minutes, right? Okay, well, let's see here. So here's the 0 output, and there's the 2 output. So basically, I'm going to write M equals what minus what on top, guys?
28 minus 62.
Over what minus what?
2 minus
2 minus 0, right? Notice this is where we're going to get our negative number, yeah? What is that?
negative 34 over 2.
Negative 34, I want to write gallons, right? I want you thinking about that. Over what? 2 minutes. And what is that per 1 minute?
Negative 17 gallons per minute.
Gallons to 1 minute. That's our rate of change. Okay? Hopefully you guys are comfortable with rate of change now. You guys, like, remember I talked to you, it's n minus beginning over n minus beginning?
Yeah.
Isn't that the same as y2 minus y1 over x2 minus x1?
Yeah.
Okay? All right. Now we want the rate of change from 2 to 4. Wheeler, and Wheeler only. For part B, 2 to 4, what minus what on top? 12 minus 28, yepper, over what? There you go. And what do we get on top?
Just Wheeler or still everyone?
Well, I think anyone can answer that. In fact, how about negative 16 over 2, which is what?
Negative 8 gallons per minute.
8 gallons per 1 minute. Just said from 2 to 4, right? Said from there to there. So it's a 12 and 28, yeah? Okay? Wow. What can you say about it? Will this be a linear relationship, guys?
No, it says not linear.
Well, before you even saw that, why won't this relationship be linear?
Because it's not constant.
the rate of change, right? For order to be linear, it needs a constant rate of change, right? Okay? So the answer to this is, why is it not linear? Because why?
The average rate of change is not constant.
The rate of change, or M, is not constant. So that is not a linear situation. That's actually, I would say, exponential. We'll get to another time. Okay? Can we read his questions here? No. Okay.